In this review problem, let's use Laplace transforms to solve this initial value problem. This is a first-order differential equation, but Laplace transforms still work. The Laplace transform of y prime is going to be s times y of s minus little y of 0 minus 3 times capital Y of s. Then for the Laplace transform of the right-hand side, let's refer to our rules. If I have t to the third e to the 3t, then I'll have 3 factorials, so 6 over s minus, and the 3 here becomes the a here, so s minus 3 to the 3 plus 1, so s minus 3 to the fourth. So that is the Laplace transform of the right-hand side. Now the object is to solve for y of s, so s minus 3 times y of s minus y of 0, which equals 1, is equal to 6 over s minus 3 times y of the fourth. So s minus 3 times y of s equals 1 plus 6 over s minus 3 to the fourth. Dividing by s minus 3, that gives y of s is equal to 1 over s minus 3 plus 6 over s minus 3 to the fifth. Okay, so now we have to find the inverse transformation of this. To find the inverse transformation, we again refer to the final rule down here, that if I have n factorial over s minus a to the n plus 1, the inverse transformation is going to be t to the n e to the at. That's kind of what I've got here. I've got n plus 1, so n is going to be 4, which means I need a 4 factorial on top for this. So let's rewrite this as 1 over s minus 3 plus 1/4 times 4 factorial over s minus 3 to the fifth. So then applying the inverse transformation of this is going to be 1/4 t to the 4. So I've got 4 plus 1, 4 factorial, then e to the 3t here. And then the rule for this one, I can use the rule that I see here. If n is equal to 0, I've got 0 factorial on top, and so I can just simply apply the rule t to the 0, e to the 3t. Alternatively, if we can use the rule found here, that if we have e to the 1 over s minus a, the transformation is e to the at, it's s minus 3, so e to the 3t. So either way, we get the solution of this first-order differential equation using the table carefully to account for the factorials in the numerator.